a very strong concertmaster is playing 440 hertz at the top of a tower. Let's draw a picture of this. So here's the ground. Here's our tower. A very strong concertmaster. They're playing 440 very precisely hertz. Of course, on the ground, we're playing the same note, what we think is the same note, right? Okay, but we're going to hear them as sharp because high clocks are fast. High clocks run fast. As we look in a place upward in a gravitational field, we see those things going faster. One way to think about it is if you think about the light, they also look, by the way, they look bluer. Okay, because as the photons, this is an incredibly strong gravitational field, right? And as those photons come down to us, we don't see them going faster. They're gaining energy, and if they gain energy, they've got to be a shorter wavelength, right? Because the energy of waves is HF, right? Can't go faster because they're light, so they gain frequency or they shorten their wavelength, right? HC over lambda. Okay, so let's use this formula here to figure out how much higher that fiddle sounds or that violin sounds. Okay, so our change in frequency is to the frequency they're playing as G, which is, look out. That's why they have to be a very strong concertmaster. 1.816 times 10 to the 14th times, the change in height is 4.5 meters, is it? And then that's over c squared. So this is going to be 3.00 times 10 to the 8th squared. Okay, and our change in frequency ends up being 3.9952 hertz, because this was hertz. Okay, so that means that we're going to hear this person on the top of the tower. We're going to hear them as we listen to them. We're going to hear 444 hertz. Why? Because this is roughly 4.00 hertz, right? Okay, so since high clocks run fast, and since frequency is how fast it's going, how frequently the string is vibrating, right? We're going to see it vibrating faster, so it's going to be 444. Okay, and then of course as we hear them, they're playing 444, and we are playing 440, and the beat frequency is just simply the beat frequency is just frequency 1 minus frequency 2, the absolute value of that. So this change in frequency, since we're playing the same note, is also the beat frequency. If you subtract 440 from 444, you'll get 4 beats per second. 4 beats per second, they're going to be sharp, and we're going to hear them at 444 hertz.